In the circuit shown, a real battery with EMF 6 volts and internal resistance of 2 ohms is inserted between points A and B. What is the voltage difference between points A and B?
Alright, so we simplified the original circuit to make it look better. So it's basically 3 parallel circuits in series, and then the next step is to find the equivalent resistance of the whole circuit.
Alright, so now to find the equivalent resistance, you take the equivalent resistance of each parallel circuit. So for this one it would be 1 over 44 plus 1 over 77. You take the reciprocal of that, you get 28. Do the same for the next one. You get 1 over 66 plus 1 over 55. You get 30. Then the final one, 56 and 140. You get 40. And now they're all in series, you can add them all up, and you get an equivalent resistance of 98 ohms.
So now that we have the equivalent resistance, we know it's given to us that the internal resistance of the battery is 2 ohms. So what we did is we took 2 ohms, divided it by the equivalent resistance, divided it by 98, and that gives us a ratio of the resistance, the internal resistance of the battery to the resistance of the rest of the circuit. And then we took that ratio and multiplied it by 6 volts, and that gives us that number, which is the voltage drop inside the battery. So then we just did 6 volts minus 0.122, and then it gives us 5.88 volts, which is the voltage drop throughout the circuit.